So I've used the rational root theorem as I've done in examples 1 through 4, listing all the factors of the constant in back, positive -1, positive -2, and so on. And then in the denominator is always going to be the factors of the leading coefficient, which happens to be 6. So I'm going to test 1, 2, 4, 5, 10, 20, and so on, hoping that one of those integer values works so I don't have to go back to fractions. So remember thinking of the acronym DMAMA. D stands for drop down, and then MA is multiply, add, until we come up with a value. So dropping down and multiplying to get 6. I'm going to add together to get -35. Hold on one second here. Pull this up really quick. Yep, then I'm going to, let's see, 1 times -35 is -35. All right, so I'm going to subtract them because they're different signs. 262, multiply to get 62. The difference here should be 6 to a -26, multiply -26, and a -6. So my output is not 0. Yes, if I was going to write y equals, and take away this, y equals, and write this as equation as a function, it is true that the order pair 1, -6, would be on that function, but I'm looking for the solutions. I want to know when is the output equal to 0. Okay, next I'm going to try -1. Dropping down 6 and multiplying. I have -47 multiplying, +47. Okay, so when I'm combining these, I get 14, carry the 1, it's 14 again. Oh my goodness, -144, 144 plus 88, oh my goodness, -232, it's a positive 232, 252. Again, output is not 0. I know that -1 is not a solution. Let's hope 2 or -2 work. Okay, dropping down the 6, multiplying to come up with 12. 41 subtract 12 is, let's see here, that's going to be a 9, carry, take away, should be 29. Okay, a larger number has a negative, and now 29 times 2 gives us, let's see, -58, and 97 subtract 58 should be 17, 8, I don't have a calculator, a 39. Now 39 times 2 would be 78. The difference here would be a -10. Multiplying is negative. Oh, I found one that works. So we can see here we finally have an output value of 0. So just like 1, -6 as an ordered pair would be on this function if it was y equals, and -1, 252 would be on that if I did all my math right. Well, 2, 0. Not only is this a solution to this equation, if this was a function written as a function, this would be a solution and it would be a y-intercept if we graphed it. So this tells me 2 works, so x equals 2 is a solution. Okay, so I should come up with 4 different solutions. I'm now going to write this as 0 equals -10, 39, add 1x, add 2x's, and add 3x's. And we'll talk about what do we do. Let me move up the paper. What do we do when it's not going to be factorable using factor by grouping? And maybe this is, but what do we do if it's not? Okay, let's check this out. Okay, so you ready? Here we go. Let's see if we can do factoring by grouping. So the most I could take out would be an x squared, and I'd be left with 6x minus 29, 6x minus 29. Is there a numerical value I can take times 6 and I end up with 39? So if I take 39 divided by 6, it's not an integer answer. It'd be a fraction. So this number does not exist when we think of it in terms of just being an integer. That means I can't factor by grouping. So what do I do? Well, I go through the exact same motions that I went through up above. So I'm going to start by circling the constant, which is -10, and I'm going to list all of the values. So we have 1, that's a factor, 2, 5, and 10. And then in the denominator, I'm going to list all the factors of 6, 1, 2, 3, and 6. Okay, so if I was going to list out all the possible factors, right, we'd have 1, a -1, 2, a -2, 5, a -5, 10, and a -10. And then I would start with 1/2, a -1/2. This just reduces down when I move over to the next denominator of 2. 2 over 2 just reduces down to 1. We're not going to repeat it, but I would have 5 halves, and negative 5 halves. So do I have to list them all? No, not unless it asks you to. You don't have to list them all. So what I'm going to do is, just like I did up above, I'm going to start by testing 1 and negative 1. And if that doesn't work, then I'm going to test 2 and negative 2. I wrote this with pen in hopes that I can test 1, negative 1, 2, negative 2, 3, negative 3, just erase it. So I'm going to write really lightly. Let's start with a positive 1, testing a positive 1. D mama, so I'm dropping down the 6. I'm multiplying. Okay, then I'm going to combine to get a negative 23. I multiply to get a negative 23. I combine, I get a 16. I multiply. Already I can see that I would just come up with a 6, and I need a 0 if it's going to work. So I'm lightly going to erase here. And now I'm going to try, there we go, I'm going to try a negative 1 really lightly. So dropping down the 6, multiplying, 6 times negative 1 is negative 6. I get a negative 35, multiplying for a positive 35. Ooh, 74, multiplying negative 74, negative 84 does not result in an output of 0. So I know 1 and negative 1 do not work. That would make sense because they didn't work for the initials up above, so it would make sense they wouldn't work for this piece. Let's try 2. Again, 1 and negative 1 didn't work up here. That makes sense since this is a part of the original equation that's also not working. Let's try 2. Okay, so drop down, multiply to get 12. Now when I combine, let's see, the different signs subtract, so I get a negative 17. Okay, got it. I'm going to multiply to get negative 34, combine to get 5, multiply to get 10. Ooh, 2 works again. So 2 worked for this equation, and 2 worked for this equation. So of the 4, I have 2 of the 4 solutions are x equals 2. And now the nice thing here is now when I rewrite this just as I did above, 0 equals, this has no x, this has no x, this has 1x, so you can see this has 1. And this has 2 x's. Now I have a choice to see, can I solve by factoring, or do I need to use the quadratic formula? So 6 times 5 is 30. I'm looking for 2 numbers that multiply to give us 30 and combine to give us negative 17. Oh, let's go with a negative 15 and a negative 2. Multiply and combine. That looks good. So remember we talked about there's multiple ways to factor, and so the way that kids voted this year that they felt like they understood best was called the AC plus B method. And so because the leading coefficient is not a 1, it's a little more work. We keep the first, the A, and then we keep the C. And now in this middle region, I'm going to take the 2 values that we decided upon that allowed us to factor this. So negative 15x and negative 2x. And so how do I know what variable comes with them? It was whatever is here. Let's see, can we factor by grouping here? So what's the most that I can factor out of 6x squared and a negative 15x? That would be a 3x. I'd be left with 2x minus 5. Let's make sure. Here's 6x squared minus 15x. What times 2x gives us a negative 2x? Negative 2x. And negative 1 times negative 5 is a positive 5. Perfect. They both contain a 2x minus 5. In front of the first is a 3x. In front of the second is a negative 1. I'm going to set each one of these factors equal to 0, and I'll solve in order to determine the 2 remaining solutions to this polynomial equation. I'm going to add 5 to the opposite side and divide by 2. So one solution is 5 halves, or you could write it as 2.5, in equivalent form and decimal form. The other I'm going to take is 3x minus 1. I'm going to add 1 to the opposite side, divide by 3, and end with positive 1/3. So these are our 4 different solutions to number 5.